chapter. Uh, as shown, the weightage is for 5 hours. Will not be able to complete in 5 hours, being it online, and the way we have to complete it, being a application subject and subject being introduced in the second year, it will take some time. Obviously, uh, the contents are vast, the application is vast. We will not be able to complete everything, but we will try to complete as much as possible within the available time, whatever we are going to get. Uh, so we have here the requirements of fuel injection system for CI engine as the first point, then the types of injection systems. Under the types, we have individual pump, common rail, distributor system. So these many systems we will be discussing under the heading types of injection system. Then we will have a unit injector type system, which we'll be again discussing. Then we have the types of fuel system, nozzles, single hole, multi-hole, pintle, and pintox. And finally, we will be discussing about the common rail direct injection system or CRDI system. So this is the content of the syllabus, what we are supposed to discuss. Moving ahead, we have now the introductory part of this first slide, in which we are going to discuss about the introduction to fuel system in CI engines. So first we need to understand what is the difference between the fuel system in SI and CI. In SI systems, we generally know that we use a carburetor, and when a carburetor is used, we prepare a mixture outside the engine, and then that particular mixture is being supplied to the engine cylinder. On the contrary, in a CI engine, we don't have a system outside the engine to prepare the mixture. Rather, we will be introducing the air only into the engine, and the fuel will be injected directly into the combustion chamber, where the mixture will be prepared there itself. So we are preparing the mixture inside the CI engine, while in SI engine we will be preparing the mixture outside the engine. So that becomes a basic difference. And since we are preparing the mixture inside the CI engine, the fuel introduction system or fuel system of a CI engine is obviously different from that of a SI engine. And that is where we need to understand what is the difference and how it is working and what are the types and so on. So obviously, some disadvantages are there in the SI engine, as we have already discussed when we use a SI system of fuel injection, where we prepare the mixture outside, and we have to use a device what we call as a carburetor, and which is a bit complex system. So we have a basic carburetor, and attached to that we have so many subsystems which together work, and the whole systems become too complex to such an extent that it becomes very difficult to service or go for maintenance or whatever we call it as. And moreover, the cost of the system also increases, because it is a bit complex system, because a small component with number of holes here and there and so many subsystems attached to it. So we have learned all this thing, isn't it? We have so what are the subsystems? We have acceleration system, we have idle system, we have uh, economizer system, and so on. So many systems attached to the basic carburetor, and that becomes that the total carburetor a complex system. And therefore it is very essential that we should overcome this particular disadvantages what we have, and for that it is better, or rather it will be advisable to go for a CI engine fuel injection system. So in the CI engines we have now different fuel injection system, and therefore we need to understand its working. The system serves the purpose of initiating and controlling the combustion to make the demand requirements. So here, starting from the starting of the combustion to the to overcoming the different demands, or satisfying the different demands, meeting the different demands, are being done by the fuel injection system. So as we have discussed in the previous lecture, again it was quality governing in case of SI engine, while in a CI engine it is a quantity governing. So that becomes again a very important issue over here. Fuel is injected there. The fuel was being directly introduced into the barrel of the carburetor where the mixture was prepared. While here we have a fuel injected into the combustion chamber directly. So that is generally done at the end of the compression stroke. So the fuel is injected into the combustion chamber towards the end of the compression, and Now, so many things related to the injection we have to take care. It is atomized as it is enter at a high velocity. The droplet get vaporized from a mixture. So all these things has to be taken care, and this will be again discussed in detail. So it is not that we are introducing the fuel and it will start burning. So when the fuel goes over there, it has to be in a proper manner. So that is where we said we are going to atomize it, and when we atomize it, the droplet size of the droplet, the velocity with which the droplets are moving inside the combustion chamber, the time required for the droplets to get converted into vapor, then the vapor is formed, the vapor mixes with air, a proper air fuel mixture need to be formed, and that mixture need to get burned, provided it is in the inflammability limit. So all these things are going to happen, and this will take a bit more time than a SI engine, and therefore it is very essential that we have this particular time available for the combustion to happen. And due to this reason, we have the CI engines to be of a lesser speed compared to that of a SI engines. So if a question is asked why ACI engines are comparatively that of a SI engines, then the answer is what we have discussed now. That is, we know that in SI engines we are preparing the mixture outside and supplying to the engine. On the contrary, in CI engines we are preparing the mixture inside the engine. So in the combustion chamber itself, we have to prepare the mixture and then burn, and that makes the more availability of the time, requirement of the time over there. And due to this particular higher requirement of time, the speed of that engine has to be lesser. That means per cycle we have to give more time to complete the cycle, and therefore generally when compared to SI engine, the CI engines are having lesser speed. Due to continued heat transfer from hot air to fuel, the fuel reaches its self-ignition temperature to ignite spontaneously, and all these things again we are going to discuss when we are going to discuss the combustion and in the different engines. Depending on the demand of the requirement of the fuel, the injection system continues to deliver the fuel during the initial part of combustion. So obviously, we know the fuel is going to be delivered directly into the combustion chamber, and the uh, as per the requirement of the power, we are going to change the amount of fuel injected into the combustion chamber. And in other words, we say we are going to change the quality of the mixture delivered to the combustion chamber. So in that manner, we are going to say that CI engines are generally quantity governed engines. So sorry, quality governed engines. In quality governed engines, when we say that the quality is going to change as and when required to change the power. So that means whenever we have a lesser power requirement, we will be injecting less fuel into the combustion chamber, and therefore the mixture becomes leaner. When we have a higher fuel requirement, we'll be injecting more power, more fuel into the engine combustion chamber, and correspondingly the mixture becomes rich. And when the mixture becomes rich, when we are burning it, we will be able to produce more fuel, sorry, more power. So that is how the higher power requirement of the engine is met in case of CI engines, and therefore we say CI engines are quality governed engines. Okay, so that is where we have a major difference coming into picture in a CI and SI engines. SI engines were quantity governed engines, CI engines are quality governed engines. So this point we have already discussed in our previous lecture. Now coming to the functional requirement of an engine, engine system, fuel system, that is for a proper engine operation and satisfactory performance, the following requirements must be met by the fuel injection system. First one, accurate fuel metering. So your fuel has to be metered accurately. That is, its metering has to be done, or in other words, its measuring has to be done properly in case of when it is being supplied to the engine. So that is the first point. That is, we need to measure the fuel properly, because we are going to introduce the fuel directly into the combustion chamber, and there, after introduction of this particular fuel, that is going to decide the quality of the mixture. And therefore it is very essential that whatever the requirement of the power is, correspondingly whatever is the mixture requirement that has to be satisfied by the supply, and correspondingly we have to ensure that the proper fuel is being supplied, and therefore the accurate metering of the fuel per cycle to meet the changing in demand and speed and load. So whatever the change in the demand is there in terms of speed or load, that means suppose we are running a vehicle at a particular speed and suddenly we want to increase the speed, what will be the requirement? Higher power. At that time we want to supply a rich mixture. Then what has to be done in this particular case in CI engines? We have to supply more fuel to the engine. That means the injection system has to be given a message that now we need to supply more fuel to the engine. That means our mixture need to be made rich, and when the mixture is going to be made rich, the power generated inside the engine will be more, and therefore the vehicle speed can be increased, or the engine speed can be increased. Similarly, when the load increases, so when the load increases, what happens? More power is required. So when the more power is required, what we need to do? We have to supply again more fuel. So when the more fuel is supplied, the mixture becomes rich, and when that rich mixture is burned, more power can be generated. So that is how, again, in other words, to meet the demand of the speed and the load, our fuel system has to ensure that accurate amount of fuel has to be supplied every time whenever the change is there. So any change in the requirement in terms of speed or load has to be taken care by your fuel system. So that is where our first point comes into picture, that is accurate measurement or accurate metering of the fuel uh, injected per cycle to meet the change in demand of speed and load. Now, the second point is the precise timing of the fuel injected in the cycle to ensure performance, power, fuel economy, and emissions. So, it is not that when you can inject the fuel whenever you want. You have to ensure that the fuel injected is as and when required, and according to the requirement of power, whatever amount of power is supposed to be generated, whatever amount of performance is we want. That means basically you in the previous cases we have learned that as per the requirement, we of the performance, we have what we call as the economy system in a SI engine. Similarly, here also that has to be taken care. So the performance has to be taken care, power has to be taken care, fuel economy has to be taken care, and emissions has to be taken care. And all this has to be taken care by your precise timing of the fuel injection system, because we know that whenever your timing of the injection is proper, then and then only we can ensure that whatever fuel is going to be introduced into the combustion chamber is going to be burned. Otherwise, if you inject the fuel in the wrong timing, then even if you inject that particular fuel into the combustion chamber, it may burn or may not burn. And even if it is going to be burned, maybe it is of no use. So the proper timing of injection is very important parameter to ensure that that fuel is being burned and converted into power, and that power is getting transmitted to the system where it is going to be utilized. So the proper timing of the injection is very, very important. Uh, Next point is the proper control of rate of injection to achieve a desired heat release pattern. Now, what this heat release pattern is, we will be discussing further. That is basically something like at what time we want what amount of heat inside the combustion chamber. So that particular pattern at which we require the amount of heat is required inside the combustion chamber for the conversion into work is what you mean by saying heat release pattern. So in order to achieve the proper heat release pattern, whatever the rate of injection is desired, that has to be met, and that has to be taken care by your injection system. So the proper control of rate of injection to achieve the desired heat release pattern during the combustion without knocking. So knocking can be another parameter or another point which need to be taken care, because knocking can happen inside the combustion chamber, and in order to ensure that knocking is not going to happen, we have to ensure a proper injection rate. So that becomes again an issue where we can ensure that by ensuring proper rate of injection, the proper heat release pattern is being achieved, and correspondingly the proper combustion. That means the combustion can be a normal combustion, it can be a knocking combustion, or while we are studying about combustion, we will be discussing about this all those things. And to ensure a proper combustion, with the rate of injection of the fuel is very important, and maintaining this proper rate is again a function of your combustion sorry injection system. Proper atomization of the fuel in the fine droplets. So you might be knowing that if you put a smaller log in a chula, it will be burning very easily, while if you put a bigger log in the chula, it is going to take more amount of time to burn. In a similar manner, if you are putting a small droplet into the combustion chamber, the its rate of burning will be different, and if you putting a bigger log or bigger droplet, it is going to burn in a different manner. So the way the combustion is going to happen is going to be decided by what is the size of the droplet you are going to introduce into the combustion chamber. And this particular droplet size is very important. So the proper droplet size which is going to be introduced into the combustion chamber is going to be decided by the injection system. So there are so many parameters related to injection system, like pressure of injection, the quantity of injection, the rate of injection, all these things, and together they decide the droplet size. And the droplet size is again being influenced by the pressure inside the combustion chamber also. So so many parameters, but what we need to understand over here is the size of the droplet has to be maintained as per the requirement to ensure. So when I say as per requirement, it should not be bigger than that, it should not be smaller than that. There are some ill effects when it is smaller, there are some ill effects when it is bigger, and therefore the optimized droplet size is very important to ensure that the proper fuel burning is going inside the combustion chamber, and it is going to burn, and proper fuel power is developed inside the combustion chamber. So proper atomization and proper droplet size is very important for burning the mixture. Then proper spray pattern to ensure rapid mixing of fuel and air. So the spray pattern has to be proper. So what is the spray pattern? So we will be again discussing in detail regarding what is this spray pattern. So if you have ever tried to spray water in the pipe when you are giving water to plants or gardening, etc., you can see that the water is going to come out of this particular jet in a certain fashion, and that particular the fashion in which it is coming out is called as a spray pattern. So specific requirement of the spray pattern is there to ensure that the droplets of proper size is going to be formed, and to ensure that it is going to be burned. So we will be again discussing related to what is the importance of spray pattern with respect to burning in the coming points. And at that time we'll come to know basically more about this spray pattern. But here at this particular juncture, we need to understand that the proper spray pattern is very important for ensuring proper burning of the mixture, and therefore the spray pattern becomes a very important parameter again. Then the uniform distribution of the fuel droplets throughout the combustion chamber is again important. It is not just enough that you are going to introduce the fuel into the combustion chamber. So whatever fuel is going to be introduced, it has to be ensured that it has to be being distributed uniformly in the combustion chamber. So if it is distributed uniformly, then we can say that yes, they are going to burn, or else it will be difficult to burn. And therefore, it is very, very essential that you have to ensure that the droplets which are going into the combustion chamber are of proper size, proper shape, proper size, and they are going to be. Yes, anybody have any doubt? Somebody has unmuted. Rahul Gaikwad, you have unmuted. Rahul Gaikwad.
Yes, sir. Yes, sir. Yes, sir.
Any problem? You mute yourself. Or any doubt? Rahul. Okay. So uniform distribution of the droplet is very essential to ensure that this particular droplets reach the combustion chamber and in that particular region, whatever air is going to be there, whatever heat is going to be there, that is being going to be absorbed, and that particular droplet is going to burn. So the droplet, if it is not distributed properly, where the droplets are more, uh, there the droplets may not burn. If the density of the droplets in a particular region is more, then they may or may not burn. And if in a particular region, if a droplet density is less, then in that particular region, the the air may be unutilized. So it is very essential that you have to ensure a uniform distribution of the fuel droplets in the combustion chamber. Then to supply equal quantities of metered fuel to all the cylinder in case of a multi-cylinder engine. So here we need to say that the fuel system has to ensure that every cylinder is made available with the same quantity of the fuel, irrespective of whichever the cylinder is nearer to system or far away from the system or something like that. So this point we have discussed in SI engines also. When we use a carburetor, we said that wherever we are fitting the carburetor, the nearer cylinders which are nearer to the carburetor system will get a richer mixture or different mixture, and a far away cylinder may get a different mixture. And similar thing, it should not happen, and that is where this particular point becomes important, that supply equal quantity of a metered fuel to all the cylinders in case of a multi-cylinder engines. That which means that suppose 8 cylinders are there, then every cylinder has to be ensured that equal amount of mixture and equal quality of mixture is going to be achieved, so that the engine will run smoothly, or else the vibration is going to happen, and that vibration may lead to the some problem in the engine, like engine may due to higher vibration may get broken, some part may broke, and then the maintenance will be higher requirement. Moreover, the comfort is going to be compromised, because whenever the vibrations are higher, the passengers will feel more uncomfortable in the vehicle, and therefore it is very essential that to increase the comfort, and you know the importance of the comfort in a modern vehicles, and therefore it is very essential that every cylinder has to be ensured that equal amount of mixture is going to be achieved. And the last point what we have to ensure is that no lag during the beginning and the end of the injection. So here we mean to say that when the fuel is going to come out of a injector, the start of the injection has to be with a very sharp start, and whenever it is going to be ending also has to be at a very sharper. Means suddenly it should start and suddenly it should end. What is going to happen if it is not going to happen like this? So suppose your injection is going to slowly start. That means slowly the fuel will come, and then your the injection will slowly go on increasing the fuel, and then it will develop into a spray pattern, and whenever it is going to end slowly so at the end and at the start there is a probability of forming a droplet at the tip of the nozzle. And you know that the temperature inside the combustion chamber is very hot, and what happens is the pyrolysis of the droplet may happen, and all this particular fuel droplet will be converted into carbon. And if it is going to be getting converted into carbon over that tip of the nozzle, then that carbon will be deposited in the holes of the nozzle, and the nozzle may get choked. So in order to prevent that, no lagging during the beginning and end of the injection is very important. So in other words, we say the dribbling has to be eliminated or removed. We don't require any dribbling in case of CI engine fuel injection system. So this was the requirement. So once again, we will revise the requirements. So we have here accurate metering, that means correct metering. Amount of the fuel which is going to be injected into the combustion chamber has to be proper as per the requirement. As per the requirement, when we say whatever is the present demand of power, speed, etc., that much quantity of the fuel has to be injected. Precise timing. The injection has to be not late, not early. It has to be at a precise timing. If it is early or late, it is going to be wastage of energy, wastage of time, and wastage of fuel. And therefore, it is very essential that your timing of the injection has to be very proper. Moreover, whatever the timing has to be there, that will ensure that your performance is going to be proper, your fuel economy is going to be better, and emissions are going to be lesser. So in order to ensure this, the proper timing is very essential, and that is why you might have heard about when sometimes when you go to the mechanic, they may say that that is a timing change bigadle vagare, isn't it? So that is the problem. So that is where the timing of the injection becomes very important. So the timing related to two things are there. If it is a SI engine, the timing is related to ignition, and here the timing is related to injection. So in SI engines, the ignition timing becomes very important, and CI engines, the injection timing becomes very important. Then we have the rate of injection. So at what rate you are going to inject the fuel? Suppose you are injecting the fuel into the combustion chamber at a very high rate. What is going to happen? The droplet may go to at a higher velocity and may end up on the wall on the other side of the engine, which should not happen, because if the fuel is going to end up on the wall, then the fuel may start on the flowing on the wall, which should not happen. Rather, the what we want is the fuel droplet has to be formed, and the droplet has to be suspended in the air inside the combustion chamber, isn't it? And that for that, the rate of injection has to be very proper, along with the size of the droplets, and that will result in a proper combustion. That is, whether your combustion is going to be normal or abnormal is going to be decided by with what rate of injection you are going to introduce the fuel into the combustion chamber. Then the size of the droplet, obviously very important. The size should not be smaller, it should not be bigger. Either smaller or bigger are going to affect, which means the droplet has to be of proper size. The spray pattern is again important. So the spray pattern, whatever you are going to get when you are injecting the fuel into the combustion chamber, becomes a very important parameter, which will ensure that uh, the droplets which are going to form are going to get sufficient amount of mixture, air for burning, and they are getting distributed properly in the combustion chamber. Then that is again correlated to next point, that is uniform distribution of the fuel droplets throughout the combustion chamber. So the spray pattern is proper, and the air motion is as per requirement inside the combustion chamber. Then the distribution of the droplet inside the combustion chamber will be also proper, which will ensure that every droplet is going to get sufficient amount of air, and every droplet is going to get sufficient amount of heat both for burning, and it is going to burn. Next point is to supply equal quantity of to every cylinder. So obviously, every cylinders require equal quantity of mixture to be supplied, or else what will happen? It will result in the vibration of the engine, and that will lead to the maintenance and higher discomfort. So that has to be taken care. Then no lag during the beginning and the end of injection. That means, in other words, no dribbling. So you might have seen in a pipe when we start a water, when the water supply is started by our corporation or panchayat, slowly initially water starts, it will starts flowing in the droplets, and then with a higher velocity it will come. It should not flow like that. Suddenly it should start, and suddenly it should end. So that is what is required. So that type of flow is what is required, which means, in other words, we say we don't want dribbling. Dribbling means coming out in the form of droplets, which is not advisable to have, which is not required to have, because if the dribbling is there, then that particular droplet which is getting accumulated on the tip of the nozzle is going to um, getting converted into carbon, and the carbon will get deposited in the holes of the nozzle, and the holes may get choked, and due to that the injection becomes improper, and then we will be requiring the maintenance of the or servicing of the fuel injection system. So these were the requirements of a fuel injection system. So these are requirements you have to keep in mind when you are saying thinking of a fuel injection system. So fuel injection system is not that easy, remember. Well, what it means that we have a notion that, well, yes, when I require more power, just introduce more fuel into the engine and it will burn. No, it will not burn. It will not burn. We have to ensure that these many things are going to happen properly. Then and then only you can ensure that whatever fuel is going to injected into the combustion chamber is going to burn, and that is going to convert it into power, and that power you are going to get utilized, because if you produce a power inside the combustion chamber at an improper time, it will be being wasted. It will not be getting converted into work which you require for the vehicle to propel. And therefore, it is very essential that all these requirements has to be satisfied properly. So that were the requirements of an injection system. Moving ahead, let us classify the injection systems. So air injection system and solid injection system is the main classification. Uh, Before going ahead, is there any doubt in whatever we have discussed, the requirements? Anybody having any doubts? Sujit Mane? Sujit? Sujit Mane, can you unmute? Sujit Mane. Sujit. व्हॉट हॅपन टू सुजित? सुजितनं पोळ्या भरपूर खाल्लेल्या दिसतात आज घरी. सुजित इज अनएबल टू अनम्यूट. ओके, शुभम गांडुळे. शुभम गांडुळे, हा, एनी डाऊट इन एनी पॉइंट?
सर सर पुन्हा एकदा शॉर्ट मध्ये अजून एकदा घेता का?
ठीक आहे, अजून एकदा घेतो, नो प्रॉब्लेम. ओके, सो द फर्स्ट पॉइंट इज ऍक्युरेट मीटरिंग ऑफ द फ्युएल इंजेक्टेड पर सायकल टू मीट द चेंजिंग डिमांड इन स्पीड अँड लोड. म्हणजे ज्या वेळेला गाडीचा लोड किंवा स्पीड आपल्याला व्हेरी करायची असते आणि त्या व्हेरिएशन प्रमाणे आपल्याला जी काही फ्युएल सप्लाय करणार आहे इंजिनला, त्या इंजिनच्या फ्युएल सप्लाय मध्ये सुद्धा आपल्याला व्हेरिएशन करावं लागतं. म्हणजेच ज्या त्या वेळेला जेवढी एनर्जी पाहिजे तेवढी एनर्जी तयार करण्यासाठी, तेवढं पॉवर तयार करण्यासाठी जेवढं फ्युएल लागणार आहे तेवढं ऍक्युरेट क्वांटिटी आपल्याला सप्लाय फ्युएल सिस्टमला सप्लाय करता आलं पाहिजे. सो दॅट इज युअर फर्स्ट पॉइंट. सेकंड पॉइंट, प्रिसाइज टायमिंग. एक्झॅक्टली ज्या वेळेला इंजेक्ट करायला पाहिजे त्या वेळेलाच इंजेक्शन झालं पाहिजे. कारण जर अगोदर इंजेक्शन झालं किंवा लेट इंजेक्शन झालं तर कदाचित जे काही फ्युएल इंजेक्ट केलंय त्याचं पॉवर मध्ये कन्व्हर्जन होणार नाही. ते बर्न होईल परंतु ती हीट वेस्ट जाईल. इट विल नॉट बी गेटिंग कन्व्हर्टेड इन टू पॉवर. कारण इंजिन मध्ये आपण काय म्हणतोय, हीट एनर्जी इज गेटिंग कन्व्हर्टेड इन टू मेकॅनिकल पॉवर. सो मे बी इट इज गोइंग टू बर्न, मे बी इट मे नॉट बर्न ऑल्सो. म्हणजे ते कदाचित बर्न होईल, न बर्न होईल, आणि बर्न झालं तरी कदाचित ते पॉवर मध्ये कन्वर्ट होणार नाही. सो इट इज व्हेरी एसेन्शियल दॅट द टायमिंग ऑफ इंजेक्शन हॅज टू बी व्हेरी प्रॉपर. म्हणजे योग्य वेळेला इंजेक्ट करणं फार महत्वाचं आहे. थर्ड, प्रॉपर कंट्रोल ऑफ रेट ऑफ इंजेक्शन. ज्या रेटने इंजेक्शन करायला पाहिजे, ज्या वेलॉसिटीने इंजेक्शन करायला पाहिजे, विथ द सेम रेट ऑफ इंजेक्शन यू हॅव टू इंजेक्ट. सो रेट ऑफ, whenever say we are saying mass flow rate or volume flow rate. ओके, सो म्हणजे थोडक्यात काहीतरी क्वांटिटी. So whatever quantity is supposed to be injected at a particular instant, at that particular instant, that much quantity has to be supplied. आणि हे का? कारण त्या क्षणाला एक रिक्वायर्ड अमाऊंट ऑफ एनर्जी आपल्याला तयार करायची, पॉवर तयार करायची, आणि रिक्वायर्ड अमाऊंट ऑफ पॉवर जर तयार करायचं तर रिक्वायर्ड अमाऊंट ऑफ हीट तयार पाहिजे आतमध्ये, आणि तेवढ्या प्रमाणात हीट हवी असेल तर तेवढ्या प्रमाणात फ्युएल आपल्याला बर्न करायला पाहिजे, आणि तेवढ्या प्रमाणात फ्युएल बर्न करायचं असेल तर पहिल्यांदा आपल्याला तेवढ्या प्रमाणात सप्लाय करायला पाहिजे. अँड टू एन्श्युअर प्रॉपर सप्लाय वी हॅव टू एन्श्युअर प्रॉपर रेट ऑफ इंजेक्शन. म्हणजे रेट ऑफ इंजेक्शन जर व्यवस्थित असेल तरच पुढच्या सगळ्या गोष्टी होणार आहेत. रेट ऑफ इंजेक्शन व्यवस्थित असेल तर योग्य प्रमाणात फ्युएल तिथे येईल, योग्य प्रमाणात ते बर्न होईल, आणि योग्य प्रमाणात बर्न झालं तर योग्य प्रमाणात पॉवर तयार होईल. सो इट इज व्हेरी इम्पॉर्टंट. आणि योग्य प्रमाणात बर्न झालं तर तुमचं कंबशन आहे ते नॉर्मल कंबशन होईल. Otherwise, the combustion may be normal or abnormal. That was your third point. Proper atomization of the fuel of the droplet. म्हणजे फ्युएल जी जाणार आहे इंजेक्टर मधून, the droplet size has to be proper. ड्रॉपलेट साइज जर स्मॉलर असेल तरी प्रॉब्लेम आहेत. काय प्रॉब्लेम आहेत आपण नंतर डिस्कस करूया. ड्रॉपलेट साइज जर मोठी असेल तरी सुद्धा प्रॉब्लेम आहे. म्हणजे whenever the fuel is going to the combustion chamber, inside the combustion chamber, the droplet size is very important. And whatever you are going to inject, that should be of proper size of droplets has to be ensured. म्हणजे जे काय ड्रॉपलेट तुमचे कंबशन चेंबर मध्ये जाणार आहे नोझल मधून, इट्स साइज हॅज टू बी प्रॉपर. then and then only we can ensure that it is going to burn properly. प्रॉपर स्प्रे पॅटर्न, स्प्रे व्यवस्थित झाला पाहिजे. आता स्प्रे पॅटर्न आपण कसं असतं, वेगवेगळ्या प्रकारचे स्प्रे पॅटर्न, ते स्प्रे पॅटर्नचे वेगळे वेगळे भाग आहेत, त्या या सगळ्या गोष्टी आपण नंतर डिस्कस करणार आहे. आपण इथं काय म्हणतोय, फक्त प्रॉपर स्प्रे पॅटर्न. स्प्रे पॅटर्न व्यवस्थित असला पाहिजे, जसा पाहिजे तसा असला पाहिजे. कारण त्या स्प्रेला एक कोर असते आणि त्याचा बाहेरचा भाग असतो, मग त्या कोर मध्ये काय वेगळ्या गोष्टी होतात, बाहेरच्या भागात मग काय वेगळ्या गोष्टी होतात. सो ऑल दिस हॅज टू बी टेकन इन टू कन्सिडरेशन अँड एन्श्युअर दॅट द स्प्रे पॅटर्न इज गोइंग टू बी प्रॉपर. देन uniform distribution. We have to ensure that the droplet reaches every corner of the combustion chamber, and the droplet is going to get every droplet, म्हणजे प्रत्येक ड्रॉपलेटला त्याच्या भोवती ऑक्सिजन पाहिजे, एअर पाहिजे, त्याच्या भोवती जी काही एअर आहे त्याची हीट पाहिजे. कारण बर्निंग होण्यासाठी त्याला हीट पण लागणार आहे, ऑक्सिजन पण लागणार आहे. आणि हे जर एन्श्योर करायचं असेल तर द distribution of the droplet inside the combustion chamber has to be proper. Then to supply equal quantities of meter fuel to all cylinders, सगळ्या सिलेंडरला एकसारख्या प्रमाणात फ्युएल रीच झालं पाहिजे, तरच एकसारख्या प्रमाणात पॉवर डेव्हलप होईल प्रत्येक सिलेंडर मध्ये, तरच तुमचं इंजिनचं रनिंग ही स्मूथ होणार आहे. जर एका सिलेंडर मध्ये वेगळ्या प्रमाणात पॉवर तयार झाली, दुसऱ्या सिलेंडर मध्ये जर वेगळ्या प्रमाणात पॉवर झाली, तर काय होईल, इनइक्वल पॉवर कमिंग to the crankshaft, and that will result in vibrations. Okay, so in order to prevent the vibration, you have to ensure that power produced by that particular cylinder, every cylinder is going to be proper, same, no lag during beginning and end of injection. So, injection start होताना आणि इंजेक्शन संपताना दोन्ही वेळेला जी इंजेक्शन होणार आहे ती शार्प पाहिजे, शार्प स्टार्टिंग, शार्प एंडिंग. ती जर ड्रिबलिंग झालं म्हणजे थेंब थेंब बाहेर आलं फ्युएल, then it is going to create problem. I hope understood. Sujit, sorry, Shubham Gandule. Shubham.
Yes sir.
हा, आता मला सांगा ड्रिबलिंग म्हणजे काय? शुभम.
फ्युएल कंटिन्युअस आलं पाहिजे सर.
बर, त्याला नाही, ड्रिबलिंग म्हणजे काय? मग ड्रिबलिंग म्हणजे काय? कंटिन्युअस आलं पाहिजे, बरोबर आहे, ड्रिबलिंग म्हणजे काय?
सर ते थेंब थेंब असं येतं ना, ते नाही आलं पाहिजे.
करेक्ट करेक्ट. तर त्या थेंब थेंब जी फ्युएल येतं फ्युएल इंजेक्टर मधून, तसं जर येत असेल तर त्याला आपण ड्रिबलिंग म्हणतो. आणि आपली रिक्वायरमेंट काय की वी हॅव टू अवॉइड द प्रिव्हेंट द ड्रिबलिंग ऑफ द फ्युएल. ओके, व्हेरी गुड. अजय सुकाळे, अजय अनम्यूट युअरसेल्फ. हा, पहिल्यांदा आलाय आज तुम्ही अख्ख्या सेमिस्टर मध्ये. काय समजतंय का काय लेक्चर मध्ये काय चाललंय ते?
होय.
हा, सांगा मग काय काय समजलं आजच्या लेक्चर मध्ये आतापर्यंत डिस्कस झालेलं. सांगा की.
पाऊस चालत आहे, मग काय येत नाही.
पाऊस चालू आहे का तुमच्याकडे? व्हेरी गुड. बर 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 बर. परंतु लक्ष देत जावं बरं का, ही अशी कारण सांगायची नाही ती. हा, कारण मी ऐकून घेणार नाही. अजय कारण ऐकून घ्यायची नाही, घेतली जाणार नाहीत. कारण आम्हाला माहिती आहे, आम्ही आता या प्रोफेशन मध्ये 20 वर्ष 25 वर्ष झालेले आहे. आम्हाला माहिती आहे मुलं का कारण सांगतात ते. तर कारण ऐकून घेतली जाणार नाही, ते लक्ष द्यायचं आणि ज्या वेळेला प्रश्न विचारायचा त्याचं उत्तर सांगायचं, बरोबर?
हो.
हा, तर इथून पुढे रेग्युलरली अटेंड करायचं लेक्चर.
हो सर.
ओके, हा ठीक आहे. आता तुम्ही पहिल्यांदा आहे त्यामुळे तुम्हाला माफ. ओके, सौरव पवार.
येस सर.
हा, व्हॉट इज हीट रिलीज पॅटर्न? पॉइंट नंबर 3.
हीट रिलीज म्हणजे प्रॉपर कंट्रोल ऑफ रेट ऑफ इंजेक्शन, म्हणजे टू अचीव द डिझायर्ड हीट रिलीज ड्युरिंग द कंबशन चेंबर विदाउट एक्सप्लोजन ऑफ फ्यूल.
व्हेरी गुड, व्हेरी गुड. हा, सौरभ, व्हेरी गुड. यू कॅन अनम्यूट. सो राईट आन्सर, हीट रिलीज पॅटर्न म्हणजे ज्या वेळेला जेवढ्या प्रमाणात पॉवर पाहिजे तेवढ्या प्रमाणात हीट तयार झाली पाहिजे, आणि ज्या वेळेला जेवढी हीट आहे त्याचा एक आपण ग्राफ ड्रॉ करतो, त्याला हीट रिलीज पॅटर्न असं नाव देतो. आणि त्याच्यासाठी रेट ऑफ इंजेक्शन इज व्हेरी इम्पॉर्टंट. ओके, व्हेरी गुड. सुहास नसते.
येस सर.
आपल्याला एमिशन कंट्रोल करायचं आहे. आपल्याला काय कंट्रोल करायला पाहिजे? हा,
प्रॉपर फ्लो ऑफ फ्यूल.
कुठल्या पॉइंट मध्ये आपण डिस्कस केलंय? हा, बोला. कुठल्या पॉइंट मध्ये डिस्कस केलं? सेकंड. व्हेरी गुड. तर आपल्याला प्रिसाइज टायमिंग मेंटेन करणं पाहिजे, कारण टायमिंग योग्य वेळेला आपण फ्युएल जर इंजेक्ट केलं तरच आपल्याला योग्य प्रमाणात बर्न होणार आहे आणि एमिशन कंट्रोल होणार आहे. सो इट इज व्हेरी इम्पॉर्टंट दॅट यू इंजेक्ट द फ्युएल ॲट अ प्रॉपर टायमिंग. ठीक आहे. नेक्स्ट, सचिन सुतार. सचिन.
येस सर, येस.
हा, व्हायब्रेशन कधी होऊ शकतं इंजिन मध्ये आणि व्हायब्रेशन कंट्रोल करायचं तर काय करायला पाहिजे? आपण आता डिस्कस केलं तर व्हायब्रेशन कधी होणार? सचिन काय झालं? आणि म्यूट का केलं सचिननं? सचिननं का म्यूट केलं? सचिन म्यूट का करतोय? उत्तर येत नसेल तर सचिन म्यूट करणार का? सचिन सचिन सुतार काय झालं? सुतार हे काय बरोबर नाही सचिन. बर ठीक आहे. सो आय विल मार्क सचिन सुतार ऍबसेंट टुडे. रोल नंबर 18 इज ऍबसेंट. सुयोग जाधव. सुयोग जाधव कॅन यू अनम्यूट? सुयोग जाधव काय झालं? हॅलो काय चालू आहे सुयोग? आम्हाला आवाज ऐकू तुम्ही ऐकावं लागलंय आम्हाला. काय चालू आहे नक्की तिथं? गाडीवर आहे तुम्ही का तुमच्या बाजूला आजूबाजूला काय ऍक्टिव्हिटी चालू आहे? काय चालू आहे? एवढा आवाज येतोय? बर 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 ठीक आहे ठीक आहे. म्हणजे तुम्ही आम्हाला ऐकण्याच्या कंडिशन मध्ये नाहीये. व्हेरी गुड. ऋतुजा कापसे. ऋतुजा.
Yes, sir.
हा. What is the importance of proper size of the droplet? What is the importance of the proper droplet size?
Sir, I don't know.
You don't know. Okay, you can unmute. Soham Overikar. Soham Overikar.
Yes, sir.
What is the importance of the proper size of the droplet?
Due to for the
Which
proper
point we
combustion
have
of the
discussed?
fuel. Third point.
Which point we discussed this?
Third point.
And
No,
what
sorry,
we
sir.
discussed
Fourth
in
point,
the
sir.
fourth point?
Proper
point.
atomization
Okay.
of fuel into the fuel droplets.
Okay. Thank you. No problem. So you can unmute. Sorry, you can mute yourself. So the droplet size is very important. Let it be. So I think the droplet size is very important. जर ड्रॉपलेट साईज कमी किंवा जास्त असेल तर त्याचा इफेक्ट जे कंबशनचे जे आहे ज्या पद्धतीने कंबशन होणार आहे त्याच्यावरती होतो. म्हणजे कंबशन नॉर्मलचं ऍबनॉर्मल होऊ शकतं प्रॉपर साईज नसेल तर. बरोबर. सो when the spray droplets being sprayed are of improper size, then the improper combustion is going to happen, and therefore it is very essential that the droplet size has to be maintained. Bandare, Rohan Bandare, can you unmute? Rohan Bandare. भंडारे गायब झाले का? रोहन भंडारे. हे बरं आहे. प्रश्न विचारला की डायरेक्ट गायबच व्हायचं. राहुल खडके. राहुल खडके. ओके जाऊ दे. सो आय थिंक टुडे सगळ्यांच्या घरी लक्ष्मी आहेत त्यामुळे बरं मला वाटतं कोण मूड मध्ये नाहीये ऐकायच्या. सो इट इज बेटर. आय विल नॉट. काय झालं? काय प्रश्न होता तुम्हाला विचारला भंडारे? मला वाटलं तुम्ही गायब झाला काय.
माझे सर खडके खडके.
खडके बर, पण त्याच्या अगोदर वडणारे आवाज दिलता मी. बरं ते नंतर खडके झाला. ओके, नो प्रॉब्लेम. बोला खडके.
सर काय लक्ष दिलं नाही सर.
कसं काय लक्ष देत नाही हो, असं कसं हा? लक्ष देत नाही, लक्ष दिलं नाही. बर ठीक आहे, असू द्या. आपल्याला काय करू. ओके, आय थिंक मला बऱ्याच जणांचं आज काही लक्ष नाहीये. ओके, सो फॉर टुडे वी विल try to end over here. Today it is sufficient. Instead of 2 hours, we were only able to conduct only for 1 hour. Doesn't matter. So once again, I will revise the points what we have discussed today, and then we will complete today's lecture. Accurate metering, योग्य प्रमाणात फ्युएलचं मीटरिंग करायचं म्हणजे मोजमाप करायचं, म्हणजे योग्य प्रमाणात फ्युएल इंजेक्शन सिस्टम मध्ये गेली पाहिजे. फर्स्ट पॉइंट का इम्पॉर्टंट आहे, कारण तरच तुमचं ऍज पर डिमांड आतमध्ये पॉवर किंवा तयार होणार आहे, ज्याच्यामुळे आपल्याला योग्य प्रमाणाची स्पीड किंवा योग्य प्रमाणात पॉवर डेव्हलप करता येईल. टायमिंग इंजेक्शनचं व्हेरी इम्पॉर्टंट आहे, कारण तुमच्या इंजेक्शन टायमिंग वरती इंजिनचं परफॉर्मन्स, किती पॉवर तयार होणार आहे, फ्युएल इकॉनॉमी किती मिळणार आहे आणि एमिशन्स किती येणार आहेत, हे सगळं डिसाईड होतं. रेट ऑफ इंजेक्शन हॅज टू बी प्रॉपर. जर रेट ऑफ इंजेक्शन जर व्यवस्थित असेल तरच हीट रिलीज पॅटर्न व्यवस्थित मिळणार आहे, म्हणजेच योग्य प्रमाणात पॉवर आतमध्ये तयार होणार आहे आणि कंबशन हे ऍज पर रिक्वायरमेंट होणार आहे. ड्रॉपलेट साइज व्हेरी इम्पॉर्टंट टू एन्श्युअर नॉर्मल कंबशन. स्प्रे पॅटर्न हॅज टू बी प्रॉपर. जर स्प्रे पॅटर्न जर व्यवस्थित असेल तरच तुमचं बर्निंग व्यवस्थित होणार आणि you can ensure that the proper fuel which you are injected into the combustion chamber is going to burn and getting converted into work. Supply of equal quantity, that is all the cylinders should be ensured proper amount of fuel, and there should not be any dribbling. The start and end of the injection has to be sharp. So these are the points what we have discussed today, and I think yes, with this particular instead of 2 hours, we are concluding in 1 hour today. Okay, in the next lecture we will revise this once again and then we will move further. So those who are understood can mark their attendance in the chat box and leave, and others can remain over there and go for asking the doubt regarding whatever we have discussed today. Any doubt anybody having regarding what has been discussed today? Requirements of injection system. कुणाला काही डाऊट आहे का? असेल तर विचारा. Any doubt anybody?